Alright, for speedometer number 3, I've decided to do both a light emitting diode and a liquid crystal display setup here. And let me just flip that around because it's going to be like that. And I'm just mocking up here to create the front panel. By front panel, I mean this section here. So on this one you can see I did off to this side, and then there, the back one here of course just has the LED on it. So what I'm trying to construct now is this container slash display unit, and the two are a bit different. So again, I'm going to do it a little bit differently. This is going to display current speed. This is going to display the 4 previous speeds. And right now I'm just trying to figure out dimensions. I just scratched building it and going by eye. What I have to be careful of if I flip this over is you can see there's a fair amount of depth to the back. This one there's pins coming up to the top. Of course I can remove the pins easily enough. I've done that before. So on the back they're kind of going to look like this. These are I2C. These and these have to be tied together. There's another port for I2C over here, but there's a jumper on there between ground and VCC. I don't know what that's all about. I think it may be easier just to go from here to the Uno, which would be, well, it's not an Uno, it'll be a Nano, to the Nano, which would be down here. But this is the start of my mock-up to try and figure out where to do things. As you can see, I got a cutout here for this guy. I'll make another cutout here for this guy. I'll figure out how I'm going to wire these together, and one step at a time. Okay, that's the size that I'm going to make it, and it's a little bigger than I want, but we'll give it a try. If I don't like it, I can always change it, but at this point that's the size. Now I just have to cut out the spots there where I indicate cutout. I put a new blade in my X-Acto knife here, so that should go well. Alright, after some cutting we wind up with this. And this will go like somewhat like that. Now to make the bottom sides and top. Okay, here's the case. I've got it blocked up, drying. Well, I guess I need to do something there. Oh, I see what I have to do. Okay. Stuff that I had to hold it on the top isn't working, so we'll just do that. Okay, I think that's better now. So that's the front and that's the back. Some blocks just to hold everything in place. Some tacky glue. And gotta let it dry for a few hours. The goal was to kind of get this mocked up tonight, and I've got to do some coating still, so I'll do that later. And wiring would be tomorrow's job. Okay, that gives you an idea of what that far one is going to look like. It's just got the holes in it now. I got work to do. So you got these two, which are the outside track around there. That one will be the inside track on that end. And then, all right, here's the completed case. See, it's built like that. It's, you know, stuff will rest in there. What I'm going to do this time, though, is I'm going to paint this to do something different rather than just have the black thing out there. I think maybe silver or gray. One time or other. This is the light emitting diode 4-digit display. I'm going to display primary speed on that. This is an LCD. The LCD, I'm going to display the last speed, the speed before, the speed before, so I'll get the last 4 speeds. And I'll also get the percentage difference between this speed and the current, this speed and this one, etc. These are both I2C, so they're pretty easy to hook up. And I got to thinking, you know, this is a patch board put together. If you didn't want to do any soldering at all and still do this, if you want to put together a patch board, you can. You know, I showed, here's the 2 I2Cs. They pick up a data and a clock from A4 and A5 on this, on the Nano. Of course, you could put a Nano in instead of, you could put an Uno in instead of a Nano and just put the wires in, so either one would work. You'd need one of these boards in order to do that, and you'd have to figure out where you're going to place it, but you could. These here photoresistor sensors here with the long, you know, pieces of wire on them, you could connect a DuPont connector, and the DuPont connectors are here's a set of male female ones. They just come all together and you just strip off however many you need. You take the 2 wires off of the photoresistor and they'll just plug into there. There's one of them in, you plug the other in and then plug the wires in over there, so you could certainly do that. But to go on, as I said, light emitting diode, liquid crystal display, those are I2C devices. And the only other thing you need is a sensor, and the sensor are these photoresistors. You can get them on eBay, plus a resistor for each one. And the resistor goes on the, let me double check, on the minus. I'm going to just double check to make sure that's true on here. I'm sure it is. Yep. So the resistor, the way I've got it set up, goes on the minus. So from minus to here. Then the sensor wire. Then one of the wires from the photoresistor. To complete the circuit, the photoresistor then goes to positive on the other one, and that goes straight to positive. And this wire in between becomes the sensor wire. It's between 2 resistors. So this resistor here, which is 1 kilo ohm, and this here photoresistor. Now the photoresistor changes its resistance dependent upon ambient light. And if there's absolutely no light, it goes to, I got it up to 50k ohms. So 50,000 ohms with no light. But an ambient light, it's around 1.5, 1.2k, depending on what your ambient light is. And if you shine a bright light on it, it'll drop to like 100 ohms or so. But if ambient light's about 1.5, you kind of want your resistor to be similar. Well, I went with 1k, so yeah, it's relatively close. If you're doing this, you may want to choose different resistors. If you do that, then you're going to have to go into the code to manipulate it. But as I say, I do all my testing and development like this. Plug this into my computer. I sometimes use my Mac. I sometimes use my Windows mainframe upstairs running Windows 8. I sometimes use my Windows laptop running Windows 10. Just depends where I am, which one I use. Just finished development on this, so I know it pretty much works. I have to run it with an actual train to find out. However, moving forward now, we need to build the stuff so it will go into its case. And in order to do that, I have to hook these 2 together, I2C from here to here, and then solder it into one of my nanos. And then for these wires and power, oh, I forgot to mention, here's a power, So this uses an external power. You use a 9-volt battery. I use a 12-volt wall wart that just plugs into here, but you can get little 9-volt plugs with 2 bare wires on the end that you could plug into there, again, if you don't want to do any soldering. Or if you use an Uno will take, what, 7 to 12 volt barrel plug DC, and you could use that in place of this nano. Either of those solutions are going to work. In any case, I need to now wire up the photoresistors with the resistor, 3 wires, so a sense wire in this case comes off of here, negative off of here, and positive off of here. I've already started to do that with this wire, but as you know, instead of using these wires, I've switched to using the Ethernet cable, the 4 pair. So I'll desolder this likely and put that on here instead. Oh, and a difference this time. Alright, so this is the Cable Geeker Cat 6 cable that I bought. And problem I have is it's really quite thin, and I have no way of stripping wire off it. I've tried different things, and you know, like this here has a blade that comes down. I thought maybe I could use that, so I tried it, and yeah, it cuts it off. Oh, cut it off that end, I see. Okay, well, I wasn't using it properly then. Let's try that again. Okay, let's see what that's like. So this time, most of the wires are not too bad, but I can see glinting copper through various spots there, which means these wires are there's the insulation's off of that one, that's off of that one, and when I want to use these to punch down, I sure as heck can't. When I want to use these to go onto this guy, I can't, not with that wire being bare there. So this cable, garbage. That's 20 bucks I'll never get back again. I don't know, maybe I'll have a use for it some other time, but I sure as heck don't now. I'll have to go back online and maybe see if I can find something that will work. In the meantime, I know it'll work. And so we have blue cable. And this is about, let's see, that's 2 feet. 1, 2, 3, 4 inches short, 44 inches long. I just threw it on the table and kind of measured it. Now we'll need to bear enough off of here to go ahead and, so with the blue cable I need to, well, I bought a package of these little guys so we can throw that on for fun, and then I'm going to have to feed the wires through for this, so I need to strip off about back to there. There we go. Expose all of those. And then see if I can find the assignment I had before. Just do the same thing. Let me get rid of this center piece here. I don't know where that went. Don't really care either. Let's see. I have on my instruction book here, there's the pin numbers and the colors. Okay. So, back to what I was doing before, or what I did before. We untwist these. Okay. There, so pull those nice and straight at the end if I can, or as straight as I can, because it makes it easier to insert. I found that out. Now on here I've got pin 1 is green and white, pin 2 is green, pin 3 is orange and white, pin 4 is blue, pin 5 is blue and white, pin 6 is orange, pin 7 is brown and white, pin 8 is brown, and then I've got, oh, this is the wrong one. Good thing I checked that. This is for the first speedometer because it has I2C connections on it, and that's not what we want. We want these directions down here. Let's make sure we got everything right. Okay, I've figured out everything, how it's going in there. I just have to align these pins with these wires. And I know pin 1 is an orange and white. So we go here with pin 1, orange and white, and we stick it in and it goes in good. And then next to it is pin 2, which is orange. Now, you saw me doing this before, and it's a little bit finicky there. The orange one's in, the orange and white one's in, and I made it long enough so that they'll come out here a bit, which is what I want. Now I'll put the rest of them in, and you don't need to watch that. Okay, so I did a quick test. Well, it wasn't actually that quick. Using continuity meter, I checked each of the pins from here, so one end on here and one end on the wire, and I verified that I matched the color code for B, which is what we're using here. And now that I've got all these guys done, that keystone, of course, is going to go into the bottom of the housing. But now that I've got everything figured out, oh, here, let's slide that over there. There we go. There. That's more fun. Anyway, now that I've got everything figured out, I need to wire in resistor plus photocell and